calculus. And this one is very simple. Suppose say you are being asked to differentiate. I'm just going to go through some steps, and I would want you to observe what is happening. Y is equal to 2x cubed. Now the differential of this is dy dx is equal to 6x squared. Let's do another one. Y is equal to 5x squared. The differential would be dy dx, change in y over change in x, is equal to 10x to the power of 1. I want you to notice what is happening to the exponent of x and what is happening to the number in front of or the coefficient of x. So that's the number in front of x. So y is equal to 10x to the power of 8, and now this is dy dx is equal to 80x to the power of 9. Do you see what has happened to the 8 and what has happened to the 10? Yes. Let's go on. Y is equal to 8x to the power of 5. And now dy dx is going to be equal to 40x to the power of 4. Now if you look carefully, when we were differentiating, that is finding dy dx, the exponent changed from 3 to 2. Here the exponent changed from 2 to 1. Here the exponent changed from 8 to 7. I think there was a mistake there. And lastly, the exponent changed from 5 to 1. So it's quite safe for us to say that the exponent is decreasing by 1. So we are sort of like subtracting 1 from the exponent of x. But what is happening to the coefficient of that x? If you look at the coefficient of that x, the 3 would go and multiply with the 2 to give us the 6. Similarly, the 2 would go and multiply with the 5 to give us the 10. Again, the 8 would go and multiply with the 10 to give us 80. And lastly, the 5 would go and multiply with the 8 to give us 40. Now, if you have assessed that, and let's say we had y is equal to ax to the power of n, what would our differential be? In this case, our differential would be dy dx, and we said the exponent is reduced by 1, so our exponent is n, so we're going to subtract 1. And the coefficient will be multiplied with the initial exponent, which is n. Remember, the n would go and multiply, and then we would have a. So the n here, the n went and multiplied with the a to give us na, and for the exponent here, we reduced it by 1. So that is the rule of differentiation. The rule of differentiation says, if you have y is equal to ax to the power of n, then dy dx would be n times a x to the power of n minus 1. Sometimes they can write it nicely because a is first in the alphabet, a n x to the power of n minus 1. This is called the rule of differentiation. This is called the rule of differentiation. So you must notarize that rule of differentiation. Okay. So this is the rule that we use to differentiate any function. So if someone gave me a function y is equal to 6x to the power of 7, I would say, oh, using the rule, my n is 7 and my a is 6. So let us multiply the n and the a. In this case, the 7 and the 6, we would get 42. And then we put our x and then subtract 1 from the exponent, which is 7. So 7 minus 1 is what? 6. So now that is how we differentiate a function using the rule. Okay, so that is a very simple way of doing things, and I hope you remember how to differentiate using the rule. There is a bit more to be done in the next video, whereby you don't just use the rule, you apply the rule through different stages. Okay, so now suppose say someone gave us a function f of x is equal to 2x cubed plus 3x to the power of 4 and minus 2x to the power of 5. Now when you are differentiating this, you are going to use the rule, not the first principle, because now this is a function. Remember I had y and I would get dy dx, but now because I have got f of x, I'll get f of x prime. That is very interesting because we're no longer using y, we're now using f of x. So we don't get dy dx, we get f of x prime, which is the same. So f of x prime would then give us, now we differentiate each function individually. So in this case, we start with the first one. There is 2x cubed. The 3 comes and multiplies with the 2 to give us a 6. And obviously we subtract 1 from the 3, we get x to the power of 2. That is fair enough. Then we go to the next one. It's plus 3x to the power of 4. The 4 will come and multiply with the plus 3 to give us plus 12. And we subtract 1 from the exponent 4. And then it will be 4 minus 1 is 3. Lastly, we go to the last function, which is negative 2x to the power of 5. The 5 will come down and multiply with the negative 2 to give us negative 10. And x, the 5 now is reduced by 1. We subtract 1 from 5 to get 4. Clearly, this is a very simple way of differentiating, and you are probably wondering, if this is so easy, then how come people are failing the trick? So we are going to progress, and these are the simpler versions, and then we'll talk about what happens exactly when people are now writing. Remember, we can also have y is equal to 3x to the power of 7 minus 8x to the power of 2. And this one, instead of giving us f of x prime, will give us dy dx is equal to, yes, you guessed it, 21x to the power of 6 minus, again, minus 16x to the power of 1. You don't have to put the 1, but I just put it there just for control.